Study design explained. Study design is the backbone of any research project, determining how data is collected, analyzed, and interpreted. Broadly, research designs fall into four common categories: descriptive, correlational, experimental, and diagnostic. Part 1. Descriptive design. Descriptive research focuses on understanding and documenting the characteristics of a population, event, or phenomenon. It answers the what rather than the why. Common methods include surveys, observations, and case studies. Surveys collect self-reported data, ideal for gauging public opinion or behavior patterns. Observations involve systematically recording behaviors in natural settings without manipulation, offering real-world insights. Case studies provide detailed examinations of a single subject, allowing deep exploration. While descriptive designs excel in providing detailed snapshots, they do not establish causal relationships or explain underlying mechanisms. Part 2. Correlational design. Correlational research examines relationships between two or more variables, assessing how changes in one variable relate to changes in another. This design is particularly useful for identifying trends and making predictions. For instance, a study might investigate the relationship between exercise frequency and mental health scores. It's critical to remember that correlation does not imply causation. External variables, or confounders, may influence the observed relationships, necessitating cautious interpretation. Part 3. Experimental design. Experimental research is the gold standard for determining causality. By manipulating an independent variable and measuring its effect on a dependent variable, researchers establish cause and effect relationships. Randomized controlled trials, or RCT, exemplify this approach, often used in medical and psychological studies. Experiments feature control groups, randomization, and standardized procedures to minimize bias. For example, an RCT might test the efficacy of a new drug by comparing outcomes between a treatment group and a placebo group. While highly rigorous, experimental designs can be resource-intensive and sometimes lack real-world applicability due to controlled conditions. Part 4. Diagnostic design. Diagnostic research focuses on identifying underlying causes of a problem or assessing the accuracy of diagnostic tools. It is widely used in healthcare, where accuracy and reliability are crucial. For example, a study validating the effectiveness of a new blood test for detecting diabetes would involve sensitivity, or the ability to identify true positives, and specificity, or the ability to exclude false positives. Diagnostic studies often use cross-sectional or longitudinal data to evaluate tools over time. This design is essential for developing interventions, but can be limited by small sample sizes or variability in diagnostic criteria.